Hi, my name is Karthik Tumala, Technical Marketing Engineer from Cisco, focusing on TrustSec. This particular video demonstration provides a high-level overview on TrustSec capabilities on Wireless 8.4, showing software-defined segmentation through SGACL enforcement on wireless access points. Before going into the details, to give a little background on TrustSec support on wireless in general, 7.4 was the first official release to support TrustSec, with dynamic SGT assignment through Cisco Identity Service Engine ICE and as Security Group Tag Exchange Protocol SXP, where WLC acting as an SXP speaker sharing the IP to SGT binding information of the wireless clients to the network devices deep in the network, like a switch, router, or a firewall. But it was only supported on central switched SSIDs. 8.3 release is when the Flex Connect was first supported with TrustSec. So apart from these dynamic SGT assignment and SXP on both central switched and Flex Connect SSIDs, another very important use case is user-to-user segmentation or peer-to-peer segmentation to block the lateral movement. Until 8.4, to implement peer-to-peer segmentation, the wireless traffic on the WLAN needs to be forwarded to the upstream switch, where the upstream switch does the enforcement. Here is the sample screenshot along with the configuration needed on the upstream switch SVI. Moving on to the TrustSec capabilities on 8.4, the latest WLC version, which extends the SGACL enforcement capabilities all the way to the access point. Instead of relying on the network devices like a switch, router, and firewall to enforce the wireless traffic, we could now enforce traffic locally on the access point. It is supported now on both central switched as well as Flex Connect SSIDs. Both Wave 1 and Wave 2 APs, which include 17, 27, and 3700, as well as 18, 28, and 3800 models, support enforcement. As far as wireless LAN controllers are concerned, the support is limited only to 5520 and 8540 controller platforms. Apart from SGACL enforcement on access point, 8.4 also provides inline tagging functionality on both 5520 and 8540 controllers. Additionally, the AP running in Flex Connect mode can do both SXP v4, the bidirectional SXP, as well as inline tagging. Before moving on to the flow details on the central switched SSID, the key benefit of SGACL enforcement is to restrict the lateral movement with user-to-user segmentation or peer-to-peer segmentation. Also, we can now share the wireless classification from access point to ASA, FTD, WSA, and CeltWatch for security policies. Moving on to the flow, the wireless LAN controller downloads the security group policies from ICE, and the controller pushes these security group policies to the access point through CAPFAB. AP downloads the security group ACLs, and by looking at the source and destination SGT group information, enforcement is done locally on the access point. The SGACL enforcement flow for the Flex Connect WLANs is pretty much similar to the central switch WLANs, where the wireless LAN controller downloads the security group policies from ICE and pushes them to the Flex Connect access point running in the branch network. So the enforcement is done on the Flex Connect APs, restricting the lateral movement. But one thing to highlight here is the Flex Connect AP in the branch can now share the IP to SGT binding information of the wireless branch users to the other campus and data center network devices, since it supports both SXPv4 as well as inline tagging. So we can enable user to data center use cases with small branch offices network with an AP itself. Here's a very good example on how hackers and attackers exploit or do data breach on the enterprise customers. Attacker sends a phishing email, and the employee who is inside the perimeter unknowingly clicks on that phishing link, and the bot gets installed and the backdoor is being established. Now the attacker sends the commands over from the C2 server. The next step would be he would be scanning the vulnerable host, and once he gets hold of the privilege account, he'll be accessing the file servers, database servers, and once he gets hold of the administrator node, he would be sending the sensitive information over to the external server. Thus, the data is breached and the system is being compromised. Here is a sample SGACL to block the malware. We would be adding this into ICE, which in turn would be pushing onto the network devices. With the same example, let's see how TrustSec can block the lateral movement. So the attacker sends a phishing email, employee unknowingly clicks on the phishing link, the bot gets installed, the backdoor gets established. But now this is only confined to that particular employee PC, and the reason being TrustSec prevents workstation to workstation scanning, blocks privilege escalation and exploitation, as well as OS fingerprinting. That way, we can block the lateral movement by doing east-west segmentation. Here is the topology which we would be using for the demo. We have ICE policy administration node in the data center along with Active Directory, DNS, and DHCP. And in the campus, we have the virus LAN controller along with ICE policy service node. And we have an AP in the campus as well as an AP in the branch, which is connecting over the MVPN tunnel, and the AP is running in Flex Connect mode. So the employees in both campus as well as branch, the communication between the employees is blocked with SGACL enforcement on the access point. So we are doing east-west segmentation by doing the SGACL enforcement on the APs. Here is the TrustSec policy matrix which would be defined in ICE. Block malware is the security group ACL which is being defined between the employees' security groups. Similarly, on the right, we have the IP address of the network devices as well as the end users. This is just for your reference before we go on to the configuration part. Let's start with the ICE configuration first before moving on to the virus LAN controller configuration. Here is the cool ICE dashboard which provides the rich contextual information of endpoints as well as network devices. Under Work Centers is where the TrustSec configuration resides. Let's go to the TrustSec components to look at the security groups which are defined in ICE. Here are the predefined security groups in ICE. You can always use them for the TrustSec policies or create a new one by just clicking the Add button. Under the components, look for the security group ACLs which are defined in ICE. Here are some of the examples like block malware, allow web, like block ICMP, and so on. Here is the sample SGACL of block malware which would restrict the lateral movement. If you look at this particular SGACL, you could see the source and destination information with the port number, but there is no source and destination IP address. Let's take a look at the authorization policy in ICE. We have used the Active Directory group called employees in the policy condition. So any user who is coming from the employee group would be matching this particular policy condition. And once the condition is met, he would be granted network access and a security group called employees would be pushed for that particular user. Let's navigate to TrustSec policy to look at the TrustSec policy matrix, which is a single pane of glass providing the entire policy which is defined in your network. We have the source groups on the left and the destination groups on the top, and the intersection between the source and destination is where the security group ACL is being pushed. Double-click the intersection between the employee security group to see the block malware ACL which is being assigned between those two groups. Let's navigate to administration network devices to see the network devices which are already being added into the ICE. Let's take a look at the wireless LAN controller info which was already added in ICE. Here is the IP address of the controller. Scroll down to take a look at the advanced TrustSec settings for the device credentials as well as the TrustSec notification settings. The device credentials needs to be matched with the ones which you define on the wireless LAN controller. And the notification updates or the notification timers are customizable. You can either use the timers or you can do on-demand COA, which is change of authorization. I already connected both employee 1 and employee 2 to the wireless SSID, so let's go to the ICE live sessions to see if the session is being established. Here are both employee 1 and employee 2 who have successfully connected to the wireless network and seen here on ICE. Scroll all the way to the right to see the authorization profiles on which you would be seeing the employee security groups which is being assigned for both employee 1 and employee 2. Now that the ICE configuration is done, let's take a look at the wireless LAN controller config. We can see the wireless LAN controller is running the 8.4 release code, and let's hop on to the wireless clients to see both employee 1 and employee 2. We can see both employee 1 and employee 2 IP address who are connected to the campus AP, and let's click on the client MAC address for more details. Scroll down to the security information under client properties. We need to take a look at the security group tag information which is being pushed by Cisco Identity Service Engine. The CTS security group tag of 4 which is being pushed by ICE is now seen on the wireless LAN controller for that particular client session. Here are the two wireless access points connected to the controller. One is the campus AP and the other one is the branch AP. For this particular video, we would be connecting the wireless clients to the campus AP. Let's hop on to Security and TrustSec to look at the TrustSec configuration on the wireless LAN controller. Click on General to take a look at the CTS device credential information along with environment data and the security group name table. Once you have the device credentials, enter, and obviously these credentials needs to be matched with the ones which you entered on ISE. Once we have that, and once we save and do a refresh, automatically the security group name table needs to be populated from ICE, and the security groups which have been defined in ICE needs to be seen over here. Click on the policy to take a look at the destination security groups as well as the security group ACLs which have been downloaded by the wireless LAN controller. So in this particular example, the employee security group tag is already being assigned by the wireless client, so the wireless LAN controller would be downloading the security group ACLs for the employee security group. Here are all the security group ACLs which have been downloaded by the wireless LAN controller for the destination security group tag called employees. Here are the access control entries for the block malware SGACL downloaded by the wireless LAN controller from ICE. Now that the TrustSec policies are downloaded by the wireless LAN controller, let's test the enforcement from the wireless client. I logged into employee 1 PC and I'm trying to ping employee 2 PC. As per the policy, the ping should be succeeded. Whereas if I try to do a telnet on some ports, it should automatically deny. I logged into the campus AP to look at the policy downloads, the CTS configuration, as well as the enforcement counters. Here is the command to look at the active IP to SGT binding information on this particular AP. So if you take a look, we have both employee 1 IP address as well as employee 2 IP address, where both have been assigned a security group tag of 4. Use the CTS role-based permissions command to look at the permissions between different security groups. Use show CTS access list to look at the access control entries of a particular security group ACL or all the security group ACLs. Successful enforcement will allow the counters to be increased based on permits and denies. Use showcts role-based counters command to look at the counters. If you take a look at the deny counters have been incremented here. So when I try to do a telnet on 445 based on our policy, we have been denied access and the counters over here have been incremented. We have successfully enforced the policy on the access point by blocking the lateral movement between the employees in the campus, and the configuration would be similar for the branch use case as well. This ends the video demonstration. For more information on TrustSec, please visit cisco.com/go/TrustSec. And thanks for watching this video.